Rogue wireless access points and evil twins. Oh my goodness, we are in for a ride. Let's begin. I'd like you to visualize that you and I are about to take a really great trip, and our airplane is about an hour and a half before it takes off, so we've got a little bit of time to kill. So we open up our wireless devices at the airport, and lo and behold, sure enough, there are some access points that are available, like McCarran Airport, free Wi-Fi. Now, before we jump on and we associate with one of those access points, we really ought to think to ourselves, could this be somebody else, not really McCarran Airport, than their access point? And the answer is, it very likely could be. In this nugget, our objective is for you and I to take a look at how easy it is to put into place a rogue access point. And here are some tools that we're going to use to get the job done. We have a familiar face. We have apt-get. We're going to use that to get some new DHCP software. It's free, it's easy, and we'll walk through that. We're going to go ahead and use Airmon. That's also one we've used before. That's how we get our wireless network interface card to go ahead and go into monitor mode with Airmon, with starting that wireless interface. We're going to use a new one right here called Airbase. What that does, it basically turns our backtrack system into an access point with all the bells and whistles that a traditional access point would have, except it doesn't do DHCP services for free. So, or by default, I should say, it's all free. So what we're going to do is we're going to add a DHCP server functionality. So it'll go something like this. So we've got a user, and this is they're going to have a laptop. So let's say it's a laptop. There we go. So this is Bob's laptop. He boots up and he looks for an access point. We are going to create this logical interface called AT0, and we're going to broadcast an SSID. Maybe we call it free Wi-Fi. We'll make it really attractive. We can call it whatever we want. So we broadcast that out. Bob associates with that access point, which is really us. We use our DHCP to dynamically hand out an IP address to this guy or this person. We hand out the default gateway. We hand out the DNS information, everything we need to, and then we configure our box to go ahead and route. So this is a fun part. So maybe we use the 192.168.2.0 network. And that's the IP address we use, or the network range we use for all of our clients. And then maybe if we're connected to 192.168.1.0, which I happen to be in this network, then I can route between them. And guess what? We can do NAT. So we can go ahead and do port address translation. So Bob, as he uses the default gateway, which will be us, like 192.168.2.1, and the traffic goes to us, we'll go ahead and use network address translation, translate them to whatever our outside address is. We can forward the traffic onto the real internet. I'm using a wired interface here for the internet connection, and I'm going to use the wireless 0 for the benefit of my new customers that I'm about to get. And effectively, I've got a man-in-the-middle attack. Bob, any traffic he sends out is going to go through me, and I'll have access to every single frame of data that Bob is sending out on the network. Let's start off on a nice clean page, not just the terminal that I'm looking at, but let's also start off with a fresh reboot. I want to point out that I've done a reboot of their backtrack system between now and the previous nugget. I've also done an update with the apt-get program. So let's do a couple basic things. I'd like you to do the same. Number one, run ifconfig just to verify that our interfaces are still present and accounted for. So there's our wired interface, Ethernet 0, and there's our wireless network interface, wireless LAN 0. The other thing I did just about an hour ago was run this command right here, apt-get space update and apt-get space upgrade. Those two commands we've taken a look at previous in a previous nugget to get our system up to speed. If you are going along these nuggets with me and you're doing it on your own backtrack system, I would encourage you, especially before this one, go ahead and use apt-get space update. That may take anywhere between 5 minutes and 10 minutes just to get the updates. And then the other command that you do after that is the upgrade command. And that would bring your system up to speed with all the packages for this Linux distribution. So again, I'm not going to run both of those commands right now because I just did about an hour ago. Part of the service we're going to offer as an access point is we're going to have clients. We have Bob's machine, for example, and Bob, if he's a DHCP client, he issues a discover saying, is there a DHCP server out there? The server gives an offer. The client says, yes, I'd like to request that offer, and then we send an acknowledgement. Now, if we want to be a really good service provider via the access point, we want to go ahead and make sure we support DHCP as a server. So let's use apt-get and go ahead and get some DHCP server software. It's really simple. We're going to use apt-get. We're going to say, I want to install the DHCP3-server. The -Y is simple. It says, please say yes to any prompts that come up, so I don't have to keep pressing enter. Now, for testing this, I installed this about an hour ago also, just to make sure that this DHCP server would work. So I'm going to run the command here again. However, it's going to say, hey, it's already installed. You're all good to go. On your system, if you hadn't yet run apt-get for this DHCP server software, it would take, I don't know, just a few minutes. It would download, install, and then you'd have it ready to go, just like I have it ready to go on this machine that we're looking at right now. That DHCP server software that was just installed, if you just ran apt-get for that software, it's going to have a default configuration file. What we're going to do is we're going to move that to a different location for safekeeping. So the mv command is for move. We're going to move the file called dhcpd.conf over to a file called dhcp.conf.backup in the event we ever need to go and grab it again. So what that leaves us with is an empty configuration file for the DHCP server function. And what we now get to do is go ahead and create this file and simply specify. Now, we're in charge. We can go ahead and use virtually any network we want to hand out IP addresses. We can hand out a default gateway that we want to. We can hand out the DNS information that we want to. And here's what I think we ought to do as a plan. We'll go ahead and we'll use the 192.168.2 network. Maybe for DNS, we could point it to ourselves if we're running a DNS server, or we could point them to 8888. That's a Google DNS server. We could say that the default gateway for them is going to be 192.168.2.1. And guess what? We'll configure our IP address on our logical AP interface. We'll configure that as .1. So they'll use us as the default gateway. And then we'll also set up routing. So, for example, if this is our access point wireless network, maybe our real wired network is 192.168.1.0, and we'll set up routing in NAT so that as Bob over here associates, that spells Bob, by the way, as he associates with us, gets an IP address, and uses us as a default gateway, we'll accept his packets coming in on our logical access point interface, and then we can route them out our wired interface off to the internet, playing the man in the middle every step of the way. So now what we're going to do is we're going to create this file right here. We took the original, we put it somewhere else and set for safekeeping as this name right there. And what we're going to do is we're going to simply create the dhcpd.conf file, the configuration file. And all we're going to do is we're going to specify things like the range of IP addresses that we're going to hand out. We're going to specify the default gateway and the DNS and everything else. And check this out. To do this, you can use any text editor you wanted to. You could run the graphical editor if we had the GUI interface started. You could run VI. Another one that I recently came across that looked like a lot of fun, it's called Nano. So just as an example, it doesn't really matter which text editor you want to use. Anyone will do fine. This one's called Nano. It's built in. You don't have to install anything extra. And if somebody's saying I want to edit or make, if you will, this file called dhcpd.conf, we'll press enter, and we have a nice blank slate to work with for this file. Now the great news is that in the Nugget download area for Nugget Labs for the series, I've got all the syntax exactly verbatim that I'm using right here. So you don't need to worry about memorizing it or trying to, copy it down off the screen. Just go to the Nugget Lab area at the CVT Nuggets website and download it, and you'll have it. So here's what we're going to do. We're going to specify that we want the least time to be 600, the max least time 7,200. These are just numbers. You could actually change these any way you wanted to. All we need to do, we're setting up basic parameters for leasing out IP addresses. The important part are the subnet. So I'm going to say it's subnet 192.168.2, and we want to go ahead and hand out the mask /24. We're also going to specify what the broadcast address is, which most computers would figure out on their own, but what the heck. We'll say the broadcast address is .255. The default gateway is going to be 2.1. That's going to be our address. You could go ahead and give it a DNS server. I'm going to put out Google's because it'll actually be used by them. And then I'm also going to specify the range of addresses. So what we have here, the critical points are, we've got the subnet that I'm going to hand out IP addresses from. The range, I'm going to hand out addresses from 51 through 100. You can do whatever you wanted to within that realm. The default gateway is going to be 2.1, and that'll be us, by the way. That's us with the happy face. Wow, what is that? I don't know what that is. Okay. So now it's us with the happy face. So we're gonna be that IP address. So when they use their default gateway, they'll be using us, and then we can route it out to the internet. We'll set up the routing as well, and the DNS server is 8888. They will need a DNS server. Otherwise, they'll try to browse or go out to the internet by name, and they won't get very far without DNS. We definitely want to have those core components included in this DHCP server configuration file. So now the tricky part. How do we actually get out of this editor? Well, this symbol right here represents the control key on our keyboard. So what I'll do is I'm going to do a control X, and with any luck, what that should do is say, okay, do you want to save the changes? And I'm going to say Y to that. Y as in, yes, I want to save the changes that are currently in the buffer. It's going to confirm the file, which is right here, which is fantastic. That's the exact file. And I'm going to press enter to confirm that. And it's set. So now if we wanted to view that file, we could actually type in more space / Etsy DHCP3 DHCPD.conf, and it would show us the content. I'm comfortable. I saw it said it was going to write it. So our DHCP server information is ready and waiting to be called upon. Our next task is to go ahead and start our wireless monitoring interface. So our wireless interface itself is wireless LAN 0. Let's go ahead and use airmon-ng to say I want to start the monitoring service on that interface. It should take just a moment, and this is a very good indicator. Now we've got Monitor 0 interface available and ready for us. Now, before we put the access point up, we might want to do a little bit of research and find out exactly who else is out there so we can use our air dump. We've used that previously. So let's take a look at what's out there before we start to go ahead and pick it. And we might want to use a channel that is not currently in use, or there's not a really strong signal there. Or check this out. If we wanted to be an evil twin, where we're putting up an access point, which is a lot of fun, where if you're putting up an access point with the same SSID as somebody else, and you want to then go ahead and use a DAuth attack, have everybody bounce, and then have them reassociate. If you're stronger to where that client is, they can reassociate with you instead of their real access point, and you can do the man-in-the-middle attack that way as well. So there's a whole bunch at 6, but those signals aren't too incredibly strong. So let's use this. On our access point, let's go ahead and use channel 6. We'll join the crowd along with the others, and let's use the actual name called Free Hotspot. That ought to get some attention. So there's no free hotspot here listed yet. We'll go ahead and use that one. Now, the syntax to launch this, the program is called airbase-ng, and there's a lot of options involved with all these commands. Now, remember how we can get context-sensitive help for those. We can go ahead and use the command with a question mark or a dash help or a dash help. It depends on the actual command. Usually, just typing in the name of the command by itself, pressing enter, will give you all the switches that you can go ahead and use. This one's pretty straightforward. We're going to specify that we want to use the name of free hotspot, we want to be on channel 6, and we want to use the Monitor 0 interface for broadcasting this signal. And that being said, let's go ahead and press enter. And poof, we're now a hotspot. Very, very fun stuff. Now, just because we're a hotspot doesn't mean that we have all the functionality set up yet. For example, we haven't turned on the DHCP server service to hand out IP addresses, and we also haven't set up routing yet. Now, we're going to need another window to launch some more commands. So if you're on Backtrack and you're not using SSH to access it, but you're on the console directly, what you can do is stop this, do a Control-C, simply type in Start X to start the graphical user interface, and then from the graphical user interface, you can launch as many terminal windows as you want in that interface. It doesn't really matter how you get to the command line interface as long as you do. So let's do this. I'm going to go ahead and right-click up here on my Secure CRT SSH session. I'm going to say go ahead and clone the session. That'll give me another tab. So I've got this SSH session currently running, and now I've got more terminal window that I can use for additional commands. So one of the things I wanted to point out, actually on the original screen here, is this guy right here. It started up this logical AT0 interface. I want you to think of that as the logical interface that represents the access point to the customers. So what I want to do is take that logical interface, and I want to make sure it's up. Now, it's probably already up, but just for good measure, I'm going to do ifconfig AT0, that logical access point interface. I want you to go ahead and come up. The next thing I want to do is go ahead and assign an IP address to this interface. Now, not just any IP address. I want to assign the IP address that I handed out or will be handing out via DHCP server services as the default gateway clients are using. So that was on the 192.168.2 network. We handed out .1 as the IP address of the default gateway. That's the IP address I want this interface to go ahead and now start using. I'm also going to add a route. Now, some of these, I went through lots and lots of examples in trying to get something that would be consistently workable for most backtrack systems. And this route statement simply says, okay, to get to the 192.168.2 network, you can go ahead and use the default gateway or the next hop of 192.168.2.1, which is, by the way, itself. If it's directly connected, which it is, to that network, you would think you wouldn't need this one route. But I found that if you don't have this route, it doesn't always work consistently. So all we're doing is we're adding a route telling the backtrack system how to reach the 192.168.2 subnet using its own IP address that's assigned to the AT0 interface. Next, we're going to start the DHCP server service. And for this one, just be grateful that the actual syntax, the actual command, you can get from the NuGet download area and not have to memorize it or write it out manually. So it's DHCP D3-CF, and then we point to the configuration file, space -PF, and then we refer to an AT0 at the end. So that tells the DHCP server function about the configuration file to use and what interface to use, for example, AT0. And now we're going to go ahead and start the service. And to do that, we're going to use /etc/init.d/DHCP3-server space and the word start. And that is what starts the service. All right, for this last piece, what we're going to do is we're going to set up network address translation, so that when traffic comes in from the client on the AT0 interface, we're going to go ahead and route it out of our, in this case, it's my Ethernet 0 interface, the wired connection. I'm also going to do network address translation. I'm going to translate the source IP address to whatever I happen to have configured on the Ethernet interface at the moment. I'm also going to set a bit on to say, you know what, we are going to forward traffic and act as a router. Basically, it's the routing function for IP version 4. Now, the actual syntax for that, I have also added, I found some really good solutions that work fairly consistently, and that's why I've included them here. So we're going to do some flushing of tables, we're going to go ahead and do some refreshes, and then we're going to set up the actual network address translation, tell it what interface to allow packets to come in on, and also how to go ahead and do the forwarding out the Ethernet 0 interface. So all this syntax, this might take quite a bit of guesswork if it weren't for other individuals who have done a lot of practice and a lot of testing to verify which commands work. So I've seen some configurations with less than this, but every time that a piece was left out, it wasn't as consistent across backtracks. So what I wanted to do is give you what I found was a working solution. So if you wanted to replicate this exactly, you could do exactly that. And also as a reminder, the actual files, the actual commands I'm doing here are in the NuGet Lab download area. So you can just copy and paste those if you want. All right, now for the moment of truth. Let's go back over here, and we haven't got anybody associated with us yet. I guess we need some customers to show up. So I've got an iPhone. I'm going to just go ahead and launch it. And on my iPhone, I am going to specify that I want to turn my Wi-Fi on. It's off at the moment. And I'm going to tell it that I want to associate with this free hotspot. And there it goes. And that's me. That's my MAC address, the one that ends in C5 right there. That's the MAC address of my iPhone. So I'm going to go ahead and open up a browser on my iPhone as well. And just to verify that I can actually get out. You know, in the browser, oh, there it goes. Finally. Woo! Not the that's a long time. So not the speediest access point, but certainly it got through. And so I'm actually looking at a web page that I'm browsing through my iPhone, and it's going through this device right here. For a second there, I thought it wasn't going to work. So if the browsing hadn't worked, I would have done a ping out to an internet resource like 8.8.8.8. to maybe see if I had a DNS issue, if I did a type on the DNS information or something else. But it looks like it's working, and that's how we become an access point on our backtrack system. You know, as a test, let me do this. Let me go ahead and launch a ping out or traceroute application on my iPhone, and that way I can verify, because I also want to make double sure that I really am going through this backtrack system. And let's go ahead and do a traceroute just to verify the correct hops are in play. So I'm going to launch traceroute, and I'm going to put in the IP address of 8.8.8.8. I've taken a picture of that as well. And I'll put that here in the post-production. And let me go ahead and do a start to 8.8.8.8. Wow, look at that. The first hop is 192.168.2.1, and then 1.1, and then it goes off to my service provider on another private network, and then it finally hits the global internet address space on hop number 4. In this nugget, we've identified how to take a backtrack system and using a wireless network interface card, make it into an access point. Clients like Bob who want to associate with us can do so. We can hand them a DHCP address, a default gateway, DNS, everything else. They can then forward traffic to us that needs to go out to the internet. We can route it on their behalf. Aren't we such good folks? And effectively, we are a man in the middle. Now, it gets a little bit better than that. Besides just offering free wireless access point services to customers, we could also do something called an evil twin. Now, what exactly is an evil twin? That's a good question. And of course, I want to point out that all of these videos in this Nugget series are all based on your own private networks, not harming anyone else, not doing anything unauthorized, etc., etc. So let's say you had personally set up an access point that said free Wi-Fi, a real one. And then you got your backtrack, and we used Airbase, and we set up another one, also called free Wi-Fi. Now, what's to prevent individuals from associating? I'll put the real one, and here I'll put the fake one. So what's to prevent users from associating with this access point instead of the real one? The answer is whichever one they have a strongest signal to, which could be the person you're sitting next to, that's going to be the one they're going to associate with. Well, Keith, what if they're using WPA or WEP or some kind of encryption? No problem. We already know how to get that. So what we could do when you use Airbase, it has lots of options for specifying the type of encryption and the keys. So if first we need to discover what those keys are and then configure Airbase using those keys, we could be an evil twin, and that way users could associate with us instead of the real access points. We could put them on a different network from an IP perspective and route them to the real network resources they want to get to. Okay, so how would we prevent something like this from happening? In a perfect world, we would have, first of all, very tough keys, pre-shared keys, if we're using WPA2. So very long passwords, like 10 characters or more, passphrases, upper, lowercase. So if they can't break our keys, they won't be able to do this to us. So that'd be the first step. Secondly, we could also use in an enterprise, you'd use something like a AAA server that authenticates the access point as part of the process. So it's not just an access point with a pre-shared key configured in it. We also have a back-end server that's doing authentication of the access point as well as doing authentication of the users who are associating with that access point. And that's a method we can use to make sure in an enterprise we're associating with the correct device. The other item is that what if we're at a coffee shop or something else and we want to use a wireless access point? How do we know it's not a rogue one? The answer is you don't. But what we could do, if this is Bob's computer, here's what we do. So we associate with an access point, whether it's hopefully it's not a hacker, but we associate with the access point. We get access to the internet, and then we build something called a VPN. And it doesn't matter really which type of VPN. You could use an SSL type of VPN or an IPsec type of VPN. But if we're encrypting all the data between us, and I'll go ahead and put this in pink, all the data between us and a server, which is our VPN head-end device, and then from the server that routes out to the internet for CNN and CBT Nuggets and whatever websites you're going to. That way we're protecting everything across this dangerous section right here, where the eavesdropper, if it's all encrypted, he won't be able to do a whole bunch with that data except turn it off because he's done supporting us. But he won't be able to eavesdrop on encrypted data successfully. I have had a lot of fun. I appreciate you joining me. The actual configuration commands used in this Nugget are in the Nugget Lab download area. I hope this information has been informative for you, and I'd like to thank you for viewing.